Alright, so welcome to all the NEET aspirants, and I know that you are excited to know that what is the physics syllabus for NEET 2024, and they are all around there so much saying that physics syllabus is reduced. Okay, so many of you might be very happy, might be partying that okay, very well, the syllabus is reduced. Now we have to study a little less. Okay, but in this video, I am here to tell you that there is nothing like that. Okay, not a lot of changes are there in physics syllabus. Okay, there are some changes in chemistry and biology though, but in physics syllabus, I may with full responsibility can say there is hardly any change, and almost you have to study everything which usually we used to do. Okay, so hardly anything is changed in the physics syllabus. So in this session, I am going to have a detailed analysis of physics syllabus. Okay, so some topics are there which are not written in the new syllabus, but why we must study them. Okay, I'll be giving you some context to that also because so many people are there. They are telling that okay, this is gone. Doppler effect is not there. This is not there. Archimedes principle is deleted. Okay, so see, it is not written, but whether we have to study this or not study this is the big question. Okay, so we'll be going through each and every unit of this physics. We'll be talking about each and every unit in this video, and we'll have a discussion that whether what to study in physics and what we can leave and what we can not leave. Okay, so guys, again, I welcome you all to your very own channel, NEET Success Simplified, and I am your physics educator, Dr. Uma Shankar Tripathi. Okay, so without wasting any of your time, let's move to the first unit of your new physics syllabus. Or when I say new, I feel like whether it is new or not, that is quite questionable. Okay, so now this is the first unit where it is written physics and measurement. Okay, okay, so like the NCRT, okay, like the NCRT, the first units are physical world and measurements. Okay, now in the same order, NEET also have disclosed this physics and measurement as the first unit of your syllabus. So in this, what is written? Let's see. So we have units of measurement, system of units, SI units, fundamental derived unit, least count, significant figure, and errors in measurement. Now, if you have studied the physics before, or if you are following my lectures of physics, then you might have seen that what we do normally in this first chapter. So we start with units of measurement, then we go for SI units, different system of units like CGS, MKS, like that. And then we talk about the fundamental, derived, and supplementary physical quantities, their units. Okay. Afterwards, we start with the dimensions. Okay. Now here they have written the dimension not after the physical units or the derived unit, but they have written it in the end. And normally, what we do, normally in the pattern of the teaching of the physics, the general pattern that most of the teachers are following. Okay, so what they do, what I do, so we teach the significant figure, error in measurement, least count, etc. in the later part of this chapter. Okay, okay. So instead of see, nothing is gone from here. Dimensions which were written in the last of the unit, it is written before. Okay, that's all. Nothing more changes. Okay, significant figure was there previously. Also, it is there right now. Also, but sir, one thing we are happy about that vernier caliper and the screw gauges are gone. Okay, because it was very typical understanding that how these practical instruments work for the measurements. So there is nothing to be happy about. Okay, it is there only. So it is not written, but it is written. But it is written in the last unit. Now, if you see the detailed syllabus, I'll come to that. Okay, I'll come to that. So see, I'll just make it quickly. I'll take you to this experimental skills. Okay. So in this unit, they have added this unit number 20. So in physics, we are having 20 units. Okay. Okay. Out of which I think 11 units are from class 11 physics and 10 units are from the class 12 physics. So in this Unit 20, see the first two things. Vernier caliper is used to measure the internal external diameter and depth of a vessel, and second, screw gauge is used to determine thickness, diameter of thin sheet and wire. So what I mean here that nothing is deleted from this first unit. Vernier caliper and screw gauge that we used to study previously, it is there only, but the only difference is now it is written in the last unit. Okay, but it is always advisable that you go for vernier caliper and screw gauges with the unit 1 itself. Why so, sir? Why so? Because see, in this we are dealing with, we are understanding the basic concept of errors, measurement. Okay, and this vernier caliper screw gauges, there is application of least count. So this is very, awkward, no? Like we learn least count in the first chapter, then we wait for the last unit, okay, to read about the vernier caliper and screw gauges, in which we will be comprehensively seeing the application of least count and errors. Okay, okay. So in this, you'll have to go for vernier caliper and screw gauge. So nothing as such has been changed. Now, coming to the second unit, which is given here. So the second unit given is kinematics. Okay, so the frame of reference, motion in a straight line. Okay, so in this we talk about the distance, displacement. Okay, the frame of reference from where you are observing the motion. Then we move for the graphs. So position time graph, that means the displacement time graph is there, speed velocity graphs are there, uniform, non-uniform motion. So when we say position time graph, so it includes everything. No, displacement time, velocity time, acceleration time, all these graphs are there. Okay, okay. Sir, only position time graph is mentioned. If you see how a question, now please think in this way. See, from my wisdom, what I think, if I am my examiner or I am my aspirant, if I want to frame a question from this part, I can certainly relate. I can certainly relate these displacement time curves with the speed, velocity, and acceleration. This is how usually the question were made. It is the same way they are going to get made again. Okay, nothing to worry about it. Okay, so position time graph is the speed, velocity, uniform, non-uniform motion. Okay, average speed and instantaneous velocity. Now, the average velocity is not written. It's obvious when you read instantaneous velocity, you can't understand instantaneous velocity without understanding the average velocity concept. And if you are understanding the concept of average speed, obviously instantaneous speed concept will also be understandable. So it is not like very much different. Okay. Okay. Now, uniformly accelerated motion, when we say uniformly accelerated motion, acceleration due to gravity. Okay, so the problem from acceleration due to gravity or the concepts of motion under gravity comes into picture. Okay, okay, then we have again velocity time, position time, relation for uniformly accelerated motion. Okay, so normally this part is from the motion in 1D. Okay, motion in a straight line. Afterwards, when we come to scalar, vector, see everything is there. Addition, subtraction, scalar and vector products are there. Dot products, cross product, unit vector is there. I, J, K. Resolution of vector is there. Then relative velocity. So when I write relative velocity, so rather than, so many I have seen some of the people are claiming the relative velocity is not there in 1D. It is written relative velocity. Now what if this, when they write relative velocity, have they mentioned the relative velocity in two-dimension plane or 1D? So obviously relative velocity then we have to understand in one dimension also, and without understanding the basics of relative velocity, how you will be able to get the relative velocity concept in the plane? So relative velocity is there. Then we have motion in a plane. When we say motion in a plane, clearly projectile motion, circular motion, everything is written there. So nothing is changed here. Nothing is changed here. Okay. Almost everything remains the same. So rolling motion is not written. Rolling is not there at all. Please understand this. Please understand this. Now for that I'll show you the third. Okay, third unit. Now here, let's first read this unit. Force and inertia. When I say force and inertia, Newton's first law, momentum. So momentum comes up. That means Newton's second law of motion comes up. Impulse. That means the application of Newton's second law. Then we have Newton's third law. recoil, and etc. Okay, law of conservation of linear momentum and its application, equilibrium of concurrent forces. Okay, okay, that means everything is getting covered here. Triangle law, law of parallelogram, everything is there. Okay, concurrent forces, Lami's theorem, everything is there. Okay, then we have a static kinetic friction. So whole of the frictions is covered, laws of friction. That means a static and kinetic friction is covered. Now rolling friction. Now please observe rolling friction. So if you say so rolling is not there, rolling motion is omitted from the syllabus. It has been reduced from the syllabus. Now you please think in this way, or just think what I'm trying to tell you here. I'm just asking you a simple question. Will you be able to understand the concept of rolling friction without understanding the rolling? Okay. So why you are focusing so much on rolling? Because I am seeing many of the videos and they are saying the rolling motion is not there. Alright. How this is possible? Okay. Please understand this. I'll just prove it further. So we have in this see rigid body rotation. So when I say in the rotational motion, rigid body motion, rotation, equation of rotational motion, comparison of linear and rotational motion. So can't the question of the rolling is asked to you in the NEET examination? If asked at all. Okay. So it is a matter of high risk, if you leave the rolling motion, because previously it used to be written there. So if you leave the rolling motion, according to me, according to my wisdom, it is a matter of very high risk. Okay. And see, in such an important position of your life, or in this important condition of your life, okay, so you cannot afford, because if you see, if one question comes out of it, okay, it is not that big topic. No? It is a topic of hardly one lecture. Okay, now for saving one lecture, if you leave 4 marks, your chances of getting the medical college of your choice, okay, is going to get reduced drastically. Okay, so 4 marks is reduced. See, it only happens to those students who are near attaining the rank. Okay, okay. So if 4 marks up and down, you may lose the preferred seat of yours. Okay, so I don't recommend you to take the risk. Okay, so and these are my recommendations. Rest it is upon you only. But in my teachings of physics, okay, for NEET examination, I'm not going to leave the rolling motion. I'll be explaining that also. Now, so laws of motion is already there. Almost everything is there. Dynamics is there. Dynamics of uniform circular motion, centripetal force and its application. Okay. So when you read centripetal force, by default you'll have to read centrifugal force. Okay. There also the application of Newton's third law will be there. The vehicle on a circular level road, vehicle on a bank road. So nearly everything from the third law of motion is there, and it is not like I'm going to tell you each and every topic in detail that where you relate. That is, in this way, this video is going to be very, very lengthy. I'm trying to focus on those points which are not really addressed till now, and I want to address that. Okay. Now moving to the fourth unit, sir, work, energy, and power. Work, energy, and power. So work done by a constant force and a variable force, kinetic potential energy. Now, in work, energy, power, when you have kinetic potential energy, when you are talking about force, work, energy theorem, so can you leave relating the momentum and the kinetic potential energy? So it is impossible. You won't be able to get any concept, right? Are you getting my point? So see what they have done. I don't know why they have they have not written a few things. Okay, but what I feel in most of the cases here, those things, even though they have not been written here, they have not been written here. You will have to understand it. Okay, okay. Then we have this potential energy of spring, conservation of mechanical energy. So spring also came up. Conservative and non-conservative forces, motion in a vertical circle. Now, see, it's interestingly, okay, motion in a vertical circle they have written here, and dynamics of uniform circular motion they have written here. So, this way, whole of the circular motion is covered. No? Okay, some part they have written in some unit, some part of it they have written in some other unit, right? Okay, okay. Now, now In the rotational motion, almost everything is there. Center of mass of two particle system, center of mass of a rigid body, basic concepts of rotational motion, moment of a force, torque, angular momentum, conservation of angular momentum in its application. Okay, so whole of the conservation of momentum is there. Then moment of inertia, radius of gyration. Okay, moment of inertia for simple geometrical object. Now, when we say simple geometrical object, okay, when we say simple geometrical object, so you see the cases of cavities will be covered, the combined body moment of inertia will be covered, because they are also comes up into this simple geometry thing. Nah? It is not that they are not into this simple geometry. Okay, okay. Now, similarly, in the gravitation also, so we have almost everything, no changes there. Universal law of gravitation is the acceleration due to gravity is variation with altitude and depth. Kepler's law of planetary motion. Okay, so planetary motion is there. Gravitational potential energy, gravitational potential, escape velocity, motion of satellite, orbital velocity, time period, energy of satellite. So almost everything is covered. Now, sir, variation, gravitation with variation of rotation, it is not there. So see, it is like a small topic. Okay. Okay, you may choose to leave it because it is not written, but I won't advise it, because see, it is just a matter of 15 and 20 minutes. Okay, if you go for it. And now simply, oh, maybe one lecture, let's take one lecture, may take one lecture, but you think that if you delete, so it is not written here, but when we say universal law of gravitation, when we say gravitational potential energy, escape velocity, so just a small topic, why not studying that? Okay. What will you do if a question came from them? Now you will write a letter to the concerned department and go for this Twitter thing. Okay, that this is not mentioned in the syllabus, but question came, so they will justify you in 100 ways that when we have written gravitation, okay, in that concept, the concept of gravitation is getting used. So why you have not studied? So that is no way, no excuse, and I hope that you are getting my point that you must read that. Okay. Then properties of solid and liquid. Sir, elastic behavior, stress strain relationship, Hooke's law. Okay, Young's modulus, bulk modulus, modulus of rigidity. Now some of saying that Poisson ratio is omitted. You cannot, how will you be able to, so there is a body, I'll tell you, there is a body. Now they say stress strain relationship. Now let's suppose there is a force acting on this direction on this body, and you are asked to find the lateral strain of this body. Now without Poisson ratio, how you are going to find this lateral strain if we don't know the Poisson ratio? Secondly, sir, Young's modulus, bulk modulus, modulus of rigidity. Now, when these three are mentioned here, you think of your own wisdom and try to think what I'm trying to tell you. See, many I have videos I have seen on this physics syllabus. They are saying Poisson ratio is not there. You need not to study that. Oh, please don't make that mistake. That is my advice to you. The rest it is up to you. But see, Young's modulus, bulk modulus, modulus of rigidity. When all these three are mentioned, how will you be able to relate them? Now, if these things are mentioned and if a question is there relating these three, okay, now what will you do? These cannot be related without using the Poisson ratio. Okay, so we have to understand the Poisson ratio. Then pressure due to a fluid column, Pascal law, effect of gravity on fluid pressure. Okay, now many says that Archimedes principle is not there. Archimedes principle we don't have to study. It's like, see, when you are talking about the pressure, Archimedes principle is what? It is the application of pressure variation over a fully submerged body or a partially submerged body. So when you have submerged a body, the pressures are acting on it, and you have written Pascal law, you have written pressure due to a fluid column. Buoyancy, the Archimedes principle, the basic of it is the difference of pressure at two faces of the solid body. Now, those different of pressure due to which the Archimedes principle is there, okay, and like People are saying Archimedes principle is not there. And how it is possible? How it is possible? When they have written is pressure. So Archimedes principle, I advise you to read. It is not that a big topic. It is a simple and very interesting topic, and it will help you understanding the equilibrium, which helps you to understand back work, energy, power, and the law of motions. Okay, okay. It helps you realizing using some concepts. Okay, then we have this viscosity. So Newton law of viscosity will be there. All the viscosity theorem. Stokes law is there. Terminal velocity is there. Streamline is there. Turbulent flow, critical velocity, Bernoulli principle, and its application. Okay. Now I don't want to mention it, but I can't resist myself. It says some of the videos says that Reynolds number is not there. Okay, Reynolds number is not there. Don't read Reynolds number. How you will be able to do the turbulent flow? Okay, so when you are talking about turbulent flow, if someone says laminar flow is not there, does it make any sense? How will you understand turbulent flow if not in the difference from the laminar flow, right? So Reynolds number is not written, but you have to study it. Okay, there are innumerous. See, physics is that kind of subject. If they would have omitted this whole chapter itself, then we could say, okay, Reynolds number is not there, this is not there, Archimedes principle is not there. But when it is written like turbulent flow, there is no way of writing, there is no need of actually writing this Reynolds number thing to it. Now, surface energy, surface tension, angle of contact, it was previously there, right now it is there. Okay, access pressure across curved surface, application of surface tension, then drop, bubble, capillary rise, heat temperature, thermal expansion is there, specific heat capacity, calorimetry is there, change of state, latent heat, so sensible heat is also there, heat transfer through conduction, convection, and radiation is there. Okay, so Newton's law of cooling is there. Okay, Stephen Boltzmann law is there, because these are very basics law of convection, radiation. Okay, Fourier's law is there, conduction. Because without them, how will you be able to read this conduction, convection, and radiation? Right. So what I'm trying to tell you, don't get trapped. Don't think otherwise. The bottom line is that you have to study everything according to the NCRT. Okay. According to the NCRT, you have to read each and everything. Okay. Now thermodynamics, thermal equilibrium, zeroth law of thermodynamics, concept of temperature, heat, work, and internal energy, first law of thermodynamics, isothermal adiabatic processes. Now, now, so if you, so those students, you can tell me in the comments, those, see, some of you might be watching this video who haven't yet started the physics or might be aspiring for 2025 or something, but those who have studied physics to some extent, they have reached to some extent. Okay, you tell me, okay, you tell me if I am wrong. Isothermal adiabatic is written, isochoric, isobaric is not written. Now, will you be able to read all these processes? Will you be able to understand these topics unless you understand these isobaric, isochoric process? Also, when it is written work, internal energy also, okay, so they can ask you these things in any of the process. Nah? They can ask you this in isochoric process. So what would you say? Isochoric process is not mentioned in the syllabus. Okay, they will say, sir, heat, work, internal energy is mentioned, so it is obvious that you have to study all these processes as well. Now the second law of thermodynamics, reversible and irreversible processes. Okay, so sir, heat engine and refrigerator is not there. Heat engine and refrigerator is not there. Okay, people say like that, but I don't believe it. You have to study this also. Okay, study this also. See, first of all, this is not that topic which is going to take like some 10 hours. Okay, if it is worth that much, then I would have said to leave it. But I'll tell you, without understanding, see, the second law of thermodynamics. So there are two statements. One is Kelvin Planck statement. One is Clausius statement. Okay. So in the Kelvin Planck statement, the whole Kelvin Planck statement talks about the heat engine. Okay, and whole Clausius statement talks about the refrigerator or heat pump. Now, how come you are going to study second law of thermodynamics and not heat engine and refrigerator? Okay, people are very happy. Okay, after if you are watching this video, I don't think you are going to be that happy. But the right thing I am doing is to tell you that what is there, don't get trapped in any of them. And like every unit you analyze, okay, every unit you think objectively, you will see that there is almost no change in the syllabus of physics whatsoever. Okay, okay. So many, I'm saying like reduce syllabus of physics. Okay, nothing is reduced. You have to read everything. Okay, so heat engine, refrigerator. Moreover, sir, Carnot cycles are gone. Carnot cycle is gone. If Carnot cycle you want to study, trust me, you are not going to understand anything about reversible and irreversible process. Because if Carnot cycle is not there, you will be getting just one statement that what is reversible, what is irreversible, and you are not going to understand anything like that. Then we have kinetic theory of gases. So nearly everything is there. There is no contradiction. Equation of a state of perfect gas, work done on compressing a gas, kinetic theory of gases, assumption, concept of pressure in the gas, okay, kinetic interpretation of temperature, RMS speed of gas molecule, degree of freedom, okay, that means Gibbs space law is there. Okay, law of equipartition of energy, application of specific heat capacity of gases, mean free path, Avogadro number. So nearly everything is there. There is no such change. Okay. Then we have oscillations and waves. Okay, we have oscillation and waves. So oscillations and periodic motion, time period, frequency, displacement as a function of time. Okay, periodic function, simple harmonic motion, its equation, phase, oscillation of a spring, restoring force, force constant, energy in SHM, kinetic and potential energy, simple pendulum, derivation of expression for its time period, wave motion, longitudinal transverse wave. So first let's talk about this part. Okay. So in oscillation and periodic motion, phasor diagram is not mentioned. Okay. Phasor diagram. So phasor diagram is not mentioned, but those who have studied this topic or know about this topic, they must be realizing that from phasor diagram, it is very easy or very less confusing to calculate the time period. So what my recommendation is, you also study the phasor diagram whether it is written or not. So damped oscillations, forced damped oscillations, they are omitted from the syllabus. Now go back to unit 20, you will see that they are mentioned, like the I have told you the vernier and screw gauge is mentioned in the 20th unit. Likewise, this is also mentioned. The damped oscillations, forced damped vibration, they are mentioned in the experimentation part, that is unit number 20. So you need not to leave that also. Okay. Now a very important thing, Doppler effect. So Doppler effect is gone. Doppler effect is a very basic principle of physics, right? It is from one of the very basic law of physics. Doppler effect is must to everyone who is studying physics. Okay, sir, we don't believe. Okay, those who have studied it, I have a question to you. How you are going to study this very important topic of beats without the Doppler effect? Okay, without the Doppler effect. Okay, so guys, even though Doppler effect is not mentioned here, you must study the Doppler effect. You must not leave the Doppler effect. You must not leave the Doppler effect. Okay, okay. Now moving ahead. So now till this 10 unit, we had this physics of class 11. Okay, so part 1, part 2, and what I also feel that they have this time merged some of the chapters, okay, like oscillation and waves. Similarly, in 12 physics also you are going to see. So electrostatic they have merged, okay, electrostatic they have merged. Everything is there in electrostatic, which we previously also used to be there. Okay, Gauss law is there, conductor insulator, torque on dipole. So if you read it, so see, I hope that PDF you already have downloaded, and if not, you must download it. So it is already there. Everything is there. Okay. Okay. Now moving to this current electricity. So current electricity also is everything is there. Sir, we don't have potentiometer. We don't have potentiometer. Okay. I hope if any of you have watched some other video also, sir, potentiometer is not there. Now, see, potentiometer on. Can you tell me on which principle the potentiometer works? So potentiometer work basically on the Wheatstone bridge, right? Okay. So when it works on the Wheatstone bridge, so when they write Wheatstone bridge here, when they write Wheatstone bridge there, okay, so can't they ask you the potentiometer? So definitely they can ask you the potentiometer. So again, don't leave this potentiometer, and also how long it is, how long it is, okay, how long it is. So it is a topic of 15-20 minutes. So why to take the risk? Okay, sir, carbon resistor is not there. Now, again, I am asking you, sir, carbon resistor, it is again, there is only one table into it. No, that table you have to memorize. So, again, a topic of 15 minutes. So, why taking this? My question is, why take risk? Okay, because these small topics, very, very small topics, see, the whole chapter is gone, that is one thing. Okay, but all this potentiometer, carbon resistor, these small topics somewhat utilizing the basic principle of this very unit. Okay, so why you are thinking even of leaving them? If you are thinking at all like that, now everything is there. So magnetic effect of current and magnetism. So they have merged these chapters. Okay, so everything is there. Magnetic dipole, current loop, magnetic uniform magnetic field, force on current carrying conductor. It is also, so. I think you have got my idea. No, you have got my idea. Now electromagnetic induction, alternating current, electromagnetic waves. So nearly the same, all kinds of electromagnetic waves are there, everything is there. Okay, resonance is there, power of AC circuit, wattless current, AC generator, transformer, okay, peak, RMS. So I hope you got my point, no? I don't want to make this video too long for you guys to get boring. You have got my idea. Okay, then in optics, okay, then in optics, reflection of light, spherical mirror, mirror formula, refraction of light at plane and spherical surface, thin lenses, then magnification, okay, okay, then wave optics. So nearly everything is there. There is nothing to leave in this. Now, in this modern physics, dual nature of matter and radiation. Okay, now they have written nuclear. See what kind of things are there. So nuclear fission, and just try to think the way I'm trying to see this thing. Okay, you will get the idea what I'm trying to tell you. Now, when they write nuclear fission and fusion, is there any need of writing radioactivity? Without reading radioactivity, how will you be able to understand about nuclear fission and fusion? Okay, and if at all they ask you a question from this nuclear fission and fusion, okay, can't they ask you a question from radioactivity? So if they ask you the question of radioactivity, you go to the code, they will tell that when the nuclear fission and fusion is written there, so we can ask the question from radioactivity. This is like very common sense thing. Okay, so don't leave anything in there also. Just try to read everything. Okay, then electronic device, semiconductor, diode, IV characteristic, okay, or and not, NAND, not, everything is there. So nothing to leave here also in electronic devices. Now, some topics, I'll tell you what smart thing they have done to make you confused. I don't know what was the intention to that. Now, many things that they seems to have reduced in the previous unit, they add everything here, like simple pendulum dissipation of energy by plotting the graph of square of amplitude and time. Okay, then meter scale, the mass of a given object by the principle of moments. So application of principle of moments comes here. Surface tension, Young's modulus of elasticity and material of a the Young's modulus of elasticity. So that is also there. Surface tension of water by capillary rise and effect of detergents. Okay, so all this thing we usually previously also studying. Right now also we have to study this. Now focal length. Okay, so focal length, people say focal length is not there. So focal length, you see this optics part is also there. Okay, this triangular prism. Okay, so what I feel that whatever is not mentioned, the ammeter, voltmeter, that also you have to study. Okay, that also you have to study. So not, they have not mentioned that in the usual unit, but in the next unit. Okay, so basically the thumb line is, guys, that you have to study nearly everything. So no syllabus, almost no syllabus change is there in physics, and you have to study everything. Okay, okay, so guys, in this video, I tried to tell you a detailed discussion we wanted to do with you, that don't get confused in the new physics syllabus, and this is basically the same syllabus that we used to follow. Okay, and some slight changes in NCRT new book is reflected in this new syllabus in terms of writing as well. Okay, so the bottom line is, the last thing I want to tell you is that read everything that is there in physics. Okay, so with this, thank you very much. I hope you find this video informative and useful for yours. So please don't forget to like and subscribe your very own channel, Need Success Simplified. So thank you very much. Have a good day ahead.